A very good morning to my dear students. I, Harita Malani, working as an assistant professor in Electronics and Communication Department of MLB Textile and Engineering College, Bhilwara. Today I am going to discuss a very important topic, 555 timer IC, which is practically oriented topic, and there are many applications related with this IC. And this IC is presently in the 6th semester of Electronics Engineering Design Lab. So I want to discuss some important parameters of this IC. So today the topic to discuss is 555 timer IC. This is the overview. So 555 timer IC is invented in 1971 and it found so many applications from toys, kitchen appliances, spacecraft, in our the electronics communication labs it is used, and it is a timer IC. By the name it suggests key that it has oscillating type of time delays, and this operates in three different operating modes: astable, monostable and bistable mode. So pin diagram of IC is shown over here. How it looks, it is an 8-pin IC. So first we will discuss the pin configuration. Pin number 1 is ground, pin number 2 is trigger input. External input we can give here. Pin number 3 is output. Pin number 4 is reset, to reset the whole IC configured. Pin number 5 is control voltage, that is VC, very important parameter. Then threshold voltage, depending on this threshold or output changes. Pin number 7 is a discharge pin, which plays an important role while the capacitor charges and discharges. Pin number 8 is plus VCC. Now inside this 555 timer IC, it works in three modes: astable, monostable and bistable. Now I will discuss the internal schematic of 555 timer IC, and it looks like this. So it has 25 transistors, 2 diodes and 15 resistors. Internal composition of IC 555 timer. So it is represented with a block diagram. It consists of two comparators, a flip-flop, voltage divider, a discharge transistor and output switch. See, it is not feasible always to draw the internal schematic diagram. So we are having one block diagram which shows very basic components of IC 555 timer. So here it is, the internal diagram. It shows, it's very simple. And see, one very important parameter, general question in practicals we ask, why it is known as 555 timer. It is known as 555 timer because at the input side we are having a voltage divider which consists of 3 identical 5K resistors. So these 3 resistors forms a voltage divider circuit, and the value of these resistors are 5K, which creates two reference voltages at 1/3 and 2/3. So what it means, here plus VCC is connected, this resistor is connected at the comparator. At this point, another resistance and third resistance which is grounded. So each resistance will have a voltage of 1/3, 1/3, 1/3, 1/3. So it is having 1/3 and 2/3 of the supplied voltage, which can range from 5 volt to 15 volt. So here we will discuss. Next, there are two comparators. So first, plus VCC is connected, range is 5 volt to 15 volt, 5K, 3 resistors are connected, potentials are divided, 1/3 VCC and 2/3 VCC. Pin number 2 and 6 are connected through two comparators. We all know what is a comparator. Comparator is a circuit which compares two analog input voltage at its positive or negative terminal, depending on whether it is inverting or non-inverting terminal. So pin number 6 is connected to the upper comparator. Pin number 2, trigger input, which is not compulsory to connect. 2 is connected to the lower comparator. These two, if the input voltage is at positive terminal is higher, then the input voltage at the negative terminal comparator will be output 1. This plus and minus. Minus is fixed with 2/3 VCC. If the pin number 6 threshold voltage goes more than this 2/3 VCC, then upper comparator output will be 1, otherwise it will be low. Vice versa, if the voltage at the negative input terminal is higher than the voltage at the positive input terminal, the comparator output will go low, that is 0. So is it clear? Very easy. Now this is the second diagram which shows the first comparator. Here we are showing some voltages over here. The first comparator negative input terminal is connected to The 2 by 3 reference voltage at the voltage divider, and the external control pin, while the positive input terminal to the external threshold pin, this positive input terminal. On the other hand, the second comparator, negative input terminal is connected to the trigger, negative terminal, positive is connected to the voltage divider 1 by 3 volts. So using this 3 pins trigger, threshold and control voltage, we can control the output of the two comparators. It can be 1, 0, 0, 1. The flip-flop will output. Now what we are doing, we are connecting this output to one RS flip-flop. We can control the output of the two comparators, which are then fed to the R and S inputs of the flip-flop. The flip-flop will output 1. The flip-flop will output 1 when R is 0 and S is 1. Vice versa, it will output 0. Q output 0 when R is 1 and S is 0, which is shown over here. This is Q and Q bar. Q bar is connected to the output pin of the IC. Pin number 7 is a discharge pin where a transistor is connected. This is going through the output pin near Q bar. So, using these 3 pins, we can control the voltage. Additionally, the flip-flop can be reset. We have seen this reset pin is connected to the RS flip-flop. RS flip-flop, it is connected and it could be reset. Is it clear? So, this is the diagram which is showing you everything. Key R is 1, Q will be 0, Q bar will be 1, and here we are connecting one power amplifier which will invert the output. If we are getting 1 at Q bar, output will be 0. So depending on the RS flip-flop values, we are getting the output. Depending on the threshold and control voltage, we are getting upper comparator and lower comparator values. The Q bar output of the flip-flop goes to the output stage or the output drivers, which can either source or sink a current of 200 milliampere to the load. The output of the flip-flop is also connected to a transistor that connects the discharge pin to the ground. This discharge pin to the ground, a transistor is connected at the discharge pin which is connected to ground. Next we will start. This is a basic concept of IC 555 timer. Now we will discuss its application. So first application is 555 timer as a stable mode. It is also known as a free running multivibrator. It doesn't have a stable state and continuously switches between high and low without application of any external trigger. So a stable mode, free running multivibrator, switches between high and low values of voltage without application of any external trigger. Here's an example circuit of a 555 timer. Stable multivibrators are again classified as symmetric stable multivibrator or asymmetric stable multivibrator. So this is a basic connection of that IC, which is very simple. We have seen the internal configuration, this dashed block diagram, internal configuration of 555 timer. Now we are connecting 3 external components R1, R2 and C to design a stable multivibrator. When we are talking about symmetric, which is in the experiment, practical experiment you have to perform to generate square wave. Square wave can be generated when duty cycle of output is 50%. 50% means for T on time and T off time will be same. It could be 0.5 millisecond T on, 0.5 milliseconds T off. So it will give you duty cycle of 50% and we can generate the square wave at the output. Asymmetric means it is not 50%. Duty cycle can be 40%, 50, 60%, 70%, 80%. Here we need only 2 resistors and a capacitor. The trigger and threshold pins are connected to each other. Trigger and threshold. See, these pins are connected to each other. So there is no need of external trigger pulse. Initially the voltage source will start charging the capacitor. Initially through this VCC, current will flow, the capacitor will charge through resistor R1 and R2. While charging the trigger, comparator will output 1. Here the capacitor will charge. The voltage across this point is 2 by 3 VCC. Here it is 1 by 3 VCC. If this voltage while charging the trigger, comparator will output 1 because the input voltage at the trigger pin is still lower than 1 by 3 of the supplied voltage. That means that the Q bar output is 0 and the discharge